Hello everyone, welcome back to lecture 2, and this is part 2. In this part we will just talk about R and RStudio in more detail, and I will just demonstrate how to run R codes directly in RStudio. So before I begin, I would like to highlight two things. The first thing is that, as you can see, I'm using this dark bluish background, so that's a color theme that we can just choose. I will just show you how to just update that setting. The second thing is that I also have different layouts, as you can just see. Like on the left hand side I have the console, and if I can just open this window, you can just see that I have my files, R packages and other things around here. Now I will minimize this. On the right hand side I have the source, which is the part that I can type my R codes and my show my R scripts. And here's another one over here, all the environment history and connection. So I will minimize this one as well. So basically this is my preference. I just chose the console on the left hand side and R scripts on the right hand side, which is not the default setting, but definitely feel free to just choose your own based on the settings that I will be showing in a second. So in order to update your pane layout and also the color options, what you need to do is to go to tools, and under tools you can go to global options. The first thing that I will just show you is the pane layout. So as you can just see, you can just decide how those four windows will just look like. So like I said, on my computer I have console on the left hand side, source on the right hand side, files on the bottom left, and environment on the bottom right. So you can just choose whichever one you just prefer. And the second thing is the appearance. So basically I'm using the RStudio modern theme, but at the same time, so in terms of the editor, I just use the like cobalt setting, so which is kind of like a dark background and colored and really nice bright colors. But you can definitely choose different color options. As you can see, you can just change, and whichever you prefer, whichever is better for your eyes, you can just choose that one. But basically this is the one that I'm using is called Cobalt basically. So alright, let's just go back to our codes. So like I mentioned in the slide, so basically we can use R for basic calculations, although we will be just using R for more advanced things, but at least just to begin with. So let's just highlight these lines. So I'll just click on the run button, and as you can see, R just executes all the mathematical operations. So, or I don't even have to highlight this. Let's say for the second line, I just put my cursor at the beginning of this line. When I just click the run button, it will just run that single line, and that way I will just get my result on the left hand side over here. You can also just select multiple things and then do all these math calculations. So let me just run this. So we will have 10 squared, and the same thing as the second one. Either we can use this or 2 stars to have the square root of 10, or whichever value you want, square root, log, exponential, cosine, and sine. So those are, like I said, basic mathematical things. But what we are going to do is mostly about data and variables. So let's just start talking about those things. The first thing that I would like to mention is how to create sequences in R. So let's say I would like to create a variable that is called x, and I want that x variable to be between 1 to 10. All those numbers, 1, 2, 3, and all the way up to 10. So rather than typing one by one all those values, I can just say 1 colon and 10, and that will give me a sequence from 1 to 10 going one by one. And as I just mentioned earlier, C is the one that combines all those values under a vector. So I will just now highlight this, run my code. Now x is defined. So in order to see what x corresponds to, I can either just say print x, run this, and as you can just see, it shows us numbers through 1 through 10, or I can simply just type x and run this one, and again it will give me the same thing. Print is a good function. However, just whenever you just define a new variable, just typing the name in the console or just in your script and then highlighting and running it will give you the exact variable in your R console. Another way of creating a sequence is also using the SEQ function, which is the sequence function basically in R. So just like in this one, in a more detailed way, I can just say that I would like to just start from 1, and I want my sequence to go all the way up to 10, and I want the increases 1 by 1 basically. So if I just run this, as you can see, I will create another sequence which is identical to the first one, but in this case I can just change it to like by 2, or 1 to 10 increases by 2, or 0.5, or things like that. So the sequence function, the SEQ function, is more useful in this case. I can also create letters rather than only numbers, letter sequences. So in this case I will just say sequence from 1 to 10, and I want it to be letters, so that will correspond to letters in the English alphabet from the first letter up until the 10th letter. So let's just do this. It will give us all the capital letters starting from the first letter up until the 10th letter. So I can also just do the same thing, and this time I can just do it lowercase, the letters, the first letter up until the 10th letter, and they are just being printed whenever I just run this code. So there are a couple of other interesting features of R, because these features will be quite useful when you just create subsets of your data sets, or create a new variable, doing recoding and things like that. So the greater symbol in R is just like this. So let's say we define R already from 1 to 10. So let's just run this. R, in this case x larger than 8, R will automatically print the values that that are kind of larger than 8 in this case. However, as you can see, R did not really give us the values. Instead, R just runs a conditional true and false statement. In this case, R just says whichever the values are larger than 8, this one corresponds to 1, 2, 3, it goes all the way up to here. This one corresponds to 9, and this one is 10. Those are the two values that are larger than 8 in this case. So I can do the same thing over here. So this time I'm just looking at the values smaller than 5. So only the first 4 values, 1, 2, 3, 4, will be the values smaller than 5. Remember, this is our x data set or x variable that we just defined. So only the first 4 values are smaller than 5. But I can also directly just see the values. But before I just come to that one, I would like to just show you the greater and equal or less or equal sign. So those are very similar too. So they function in the same way, but this time we just include 8 or equal, or 5 or less than 5. So now let's just say that we would like to print the values of x rather than true false values, the real values. So if I just say that x, and using the brackets, x, using the x variable, and all the elements of x larger than 8, print this. So it will give me 9 and 10. And if I just want to print values less, equal, or less than 5 with an x, and I just define it as like this, so it prints the values. Or I can just one by one write true or false. Let's say I would like to print the first 4 values and the last 2 values over here. I just specify true and false for each. So now, as you can see, 1, 2, 3, 4, the first 4 values, because I just specified true over here. Or 9 and 10, again I specify true. Instead of true and false, you can also type T and F, so that will give you the same outcome again, just like the previous one. So also the final thing is that we can just use this vertical line to create an OR statement. So in this case, I'm just saying that give me values larger than 8 or smaller than 5. So in this case, R will just print all the values larger than 8, which are 9 and 10, and all the values smaller than 5, those are 1 through 4. So again, these are the basics. So let's just move to the second step, which are like all those all those new variables, data sets, and other things, they will be our main focus in this course. So let's say I would like to create two variables. One is called weight, the other one is called height. So in weight, so I just put like 85 kilograms, 60, 56, 90, 65. So I'm defining this as if, each one corresponds to one person, for example. I just define this variable. And the same as like height, 1.8, 1.6, 1.65 meters, 1.90, 1.70, and I'm just defining a height variable, which also has 5 elements. So cities, like I said, we can also create some text-based variables. In this case, I'm just defining 5 cities over here. So Madrid, Lisbon, Montreal, Los Angeles, Rome. And it goes like gender, so male, female, female, male, female, and I just define this, and I will run these variables as well. So now I'm creating individual variables, but when we just deal with data science, we typically have data sets. And data set is a collection of variables, basically. It belongs to the same, and those variables just belong to the same group of people or observations, basically. So in this case, what I will do is that I will put all these variables into a data set called data_1. So I'm just saying that I would like to create a new data set called data_1, and this data type will be a data frame. I'm using data.frame. I open the parentheses. So I would like to create an ID variable which goes from 1 through 5. Just like we discussed earlier, I'm using a sequence rather than typing 1, 2, 3, 4, 5 individually. So I'm just defining a new variable called height, and I'm just putting the variable height that I already defined over here. And I'm creating a new variable called weight in this data set, which is already the variable that we have defined here. The gender is here. And this time, like as you can just see, like just pay attention to this part. So I just create a variable called location. So I don't have to call it cities and anything, just to show you that. So these are the names that I will be using in my data set, even though all these unique variables that we just defined here, they come up with different names. So location instead of cities, but I'm using the cities to fill that variable in my data set. So now I will just run this. And in order to print my data set, we will use again either the print function. Over here it will print, or we can directly type data equals to data_1 and run this, and again R will print the same values. So now, even though we will have a full lecture on data summarization, data wrangling, and how to clean up data sets and other things, but I would like to begin with some basic functions of R to clean up data, to create new variables, new data sets, and things like that. So we will here install two packages that will help us, and I will just install those packages and also activate them. So as you can see, so right now my computer is connected to the internet. So R installs those two packages, and the library function will activate those packages one by one. Alright, so one of the functions that we will be using in this lecture is called mutate. So the mutate function comes from the dplayer package. So in order to see, for example, like how this mutate function really works, I can type $mutate and just run this, and it will just show me how this function really works, what are the input values that I just need to define. So basically every single function in R will have that kind of like a help package, and the details, the level of details in this help pages will be based on how much the authors of that package just worked on the examples and details. But most of the time it is pretty useful. So whenever you wonder about a certain function, how it really works, just type $and the name of the function, and that will give you the help page. So let's just minimize this. So now I'm using this symbol, which is called a pipe. I'm just using mutate function together to add new variables into my data set. So I'm just saying that. So right now it is data underscore one. It is the same data set. And in this case, I'm just using the same data set over here. And the pipe will send this data set into the mutate function to be used. So basically that would place data underscore one into the mutate function. And I'm just saying that now I would like to create a new variable called BMI index, the body mass index. So it is the weight divided by the square of height, comma. I'm just defining a new height variable. I called it height2. I already have a variable which is called height, so I cannot define a new variable with the same name. So let's say initially I defined the height as meters. Now I would like to use it as like centimeters, so I multiply it by 100. And finally, after comma, I define a new weight variable. Initially, I had used weight as kilogram, but let's say I would like to create a new weight variable and I called it weight2, and I would like to specify the weight as pounds rather than kilogram. So now I will just run this, and mutate function will give us a new data set. Again, I still call it data underscore one. It will overwrite our existing data, keep the variables that we have already defined, and it will create new variables based on how we just defined them here. So I'm just running this, and as you can see, differently from the first data set that we have already seen. So now I have three additional columns. So I have BMI, height 2, weight 2, and I just defined them based on the existing variables in data underscore 1. So of course this is a small data set. So let's just take a look at a data set that is larger so we can just do more operations on it. So in R, whenever you install R, so R comes with a lot of data sets, base data sets that could be useful for like trying different functions or playing around with certain functions and then just practicing your skills. So basically, the package that I would like to, the data set that I would like to use is called, in this case, is called mtcars. So to activate this data set, which is already installed with the base R, so I just say data and I specify the name of the data set. Now I will run this. Now mtcars data set is active in my R session. So let's just see the content of this data set. So as you can see, there are many rows, there are a lot of variables. So this data set is about cars and their mpg, miles per gallon, number of cylinders, and a couple of other variables that we will be just using in the next few examples. But basically, if you like to see what this data set is all about, again, just like we did with the function, so you can just say that question mark empty cars. It will open the help page. It will just say that empty cars is a data frame with 32 observations, in other words 32 rows, and we have 11 variables, and each variable is defined here. So mpg is miles per gallon, number of cylinders, displacement, gross horsepower, and it goes like this. So you can see the details of the data set over here. There are, like I said, there are also a lot of other data sets that could potentially be used by you and other R users. They are all freely available within R. In order to see the full list, you can just run this data statement. So that will open all the available data sets in R. So the only thing that you need to do is whenever, let's say, just you would like to call this data set, copy the name and data and within the quotations. So I'll just call, and now this data set is also active. So like I said, you can scroll down and see all the interesting data sets that you may want to just play with. So feel free to just practice what you will learn from this class, this lecture, with the data sets available over here. So let's also just talk about how to import external files. So let's say you have an external text file. So in this case, I created a hypothetical line. So let's say I have a data set which is on my desktop and it is called data.csv. It's a comma separated file. In this case, comma separated files can be easily just read by using just this read.csv function. So the read.csv function will find this data set over here, which is the path, so that I specified. Remember, like I mentioned earlier, we are using the front slash rather than backslash, otherwise R does not recognize this. Header equals to true means that my data set, the first row has the variable name, so R will just skip that line and it will accept those variable names or texts or labels as the variable names when we just open the data set. But like I said, instead of just specifying the whole data path, I can also just change my working directory to desktop. And if I just do this, since the data set is already on my desktop, I should be able to read data without specifying the full path. The only thing that I need to do is just to specify the file name. So this is the comma separated files. So, and how about like you have regular text files with a .txt extension, and maybe the separator between your values is semicolon. So then you need to specify this using the read.table, and this time the separator has to be specified in a semicolon. So let's say you have a data file, but this time your columns or your variables are separated by tab, and we use this \t as a separator over here, and again using the read.table function, which can just read the data files again. So lastly, if we just go back to how to install packages and other things, one function and package that I really appreciate is this xlsx. So that's a package that allows you to import Excel files directly into your computer rather than saving them as a comma separated values or other files. You can just install this package and activate it. So, and that's exactly what I will do over here. And let's say again on my desktop, I have a data set called xlsx. So that's an Excel data set, and the sheet name for that data set, for example, let's say the sheet 1, or if there are multiple sheets, it is better or important to just specify this, otherwise R won't know how to find this, how to find the right sheet that we would like to read in. So using the read.xlsx function, so we can just read Excel files. And finally, the final package that I would like to mention is foreign package. So again, I will just install and activate this package. The foreign package has functions to open a lot of different data files. So I only just mentioned the SPSS one over here. Read.SPSS will allow you to just open SPSS files directly in R. So, and then .data.frame means that the data that we are reading in will be turned into a data frame. So, and again, there are a couple of other functions in this package, so you feel free to check this out. For example, SAS files and other files could potentially be opened in R using this package. Alright, let's go back to our empty cars data set. So let's say I would like to choose a particular column from this data set rather than seeing the entire data set. Remember, this data set already has a lot of variables. So I'm interested in only the MPG column. So how can I do that? So in this case, I just type empty cars, which is the name of my data file, $sign. The $sign will just follow a variable name or column name. So if I just say empty cars, $sign, MPG, it will only pull the first column of my data set. And let me just run this. So in this case, as you can see, 21, 21, 22.8, or things like that, just like over here. So now I only printed the first column rather than everything else in my data set. I also just can display multiple columns. In this case, I cannot use the $sign anymore. So I need to use the C function again. And I would like to just, let's say, print MPG, CYL, the cylinder and displacement, or display the variables. and I just specify the names, and again the names come from the names in the data set. I just say I would like to see mpg, cyl, and this. So I just specify this, run it. So it will only print the first those three specific columns. Let's say in here, as you can see, before comma I didn't put anything. So that means I would like to print these three variables. However, I would like to see it for all 32 rows. How about I would like to see these three columns, but only for the first three rows? Then in that case, I can create a sequence in the same way that we talked about before, 1 to 3. So in this case, I would like to see the first three rows and this three specific columns. So I will just run this. So that way it only prints the first three rows, just like we asked for, and also it prints this like three variables that we have already specified. So if you don't like seeing the data set like this, like in the console, you can also just use the view function, which is quite useful. Let me just run this. So you will just see that R will open a new window over here. Now you can really see your variables as if you are seeing it in Excel, SPSS, or similar program with a better user interface. So I can also preview my data set by printing the first 6 rows. So the head function by default prints the first 6 rows of the data set. So let's say head empty cars, it will give me only the first 6 rows of this data set for all of the variables. And the tail is also a similar function, but this time it prints the last 6 rows of the data set. So let me just run this. This time we will only just see the last 6 values in the data set, or 6 observations. So you can also customize the number of rows that you would like to see. Let's say I only want to print the first 3 values. In this case, I just say head, name of my data set that I would like to print only the first 3 rows. I use 3, so it will print only the 3 values, 3 observations over here, or last 4 rows, and I specify 4 over here. So it will work like this. A couple of other interesting functions that will be quite useful is that one is dim. It gives you the dimensions of your data set. If I run the dim function for empty cars, so it will give me 32 and 11. So it pretty much like says, in our data set we have 32 rows and 11 columns. So which is quite useful because whenever you have a huge data set, you may not want to open the entire data, and in that case you may not really know how many rows you have or how many columns you have. So this function tells you about the dimensions of a data frame. The second useful function is called str. So str stands for this structure basically. So if you just type str empty cars, it will give us a structure of content of that data set that we have, empty cars data set. So basically when I run this, the first statement is kind of like a summary. It says we have 32 observations coming from 11 variables, and each of my variables are specified over here. It shows the type of the variables. In this case, what my variables are numerical variables, and it also previews some of the values in the data set like that way. So you can see how the data really looks like without printing the full data set. So let's say I would like to do some basic recoding. I would like to create a new variable, and in this case I would like to recode the AM variable, which is the transmission type, or I would like to just use this VS variable, and I would like to create a new one because initially they are only like 0 and 1, 0 and 1. And I would like to just say that based on the information I have seen from the empty cars package, empty cars data set in the help file. So I know that 0 is already corresponds to automatic transmission and 1 is manual. In this case, VS is going to be V-shape versus straight. So again, that's from the data definition in the help page. So So I'm using the mutate function again. I'm just putting the empty cars function using the pipe. Pipe sends the empty cars function into the mutate function, empty cars dataset into the mutate function. And in this case, I'm just defining two new variables using the recode function. So AM2 will be based on the existing variable called AM. So 0 will be recoded as automatic, while 1 will be manual, comma. My new variable is called VS2, which will be recoding VS, and I guess 0 will be V-shape, 1 will be straight. So I'm just running this, creating two new variables, and as you can see now we have these two additional columns based on the columns that we already had, VS and AM. So let's say I would like to subset my data set. So how can I just choose specific cases that meet a certain condition? In this case, I'm using the filter function from the dplyr package. So I would like to choose only the cars that have automatic transmission and horsepower will be larger than 70. So I'm just saying that empty cars over here, the pipe, it sends the empty cars into the filter function, and my condition is that the transmission related variable, which is AM2, should be equal to automatic, and as you can see, I'm using double equal sign, which creates the conditional if equal statement. And I'm using the and sign over here, and just the second condition is that horsepower should be larger than 70. So let's just do this and define the new dataset as empty cars underscore 1. So based on my subset, as you can see now, all the variables in this new dataset, empty cars underscore 1, they have the automatic transmissions. I eliminated the other manual cars. I also looked at the cars with horsepower larger than 70. So in this case, if you just check the horsepower, as you can see, all the horsepower will be higher than 70. We can also just choose both rows and different columns. So let's say not only I would like to filter cases that have automatic transmission and horsepower larger than 70, and I also want to print only MPG, CYL, and DISP, the display variables. So I use the first pipe, which sends empty cars into the filter function, and this is my conditional statement. And then I close the parentheses. I use a second pipe, which will send the outcome of this part into the select function. In the select function, basically our dataset, filter dataset, will come over here, and my dataset will only just keep MPG, CYL, and DISP. So let's just do this and then see our new dataset, which I will call empty cars underscore 2. Again, this is the very similar data set as before, but I only kept 3 columns in my data set rather than everything else. So few summary functions, how to summarize data in R. So the base R has a function called summary, which is quite useful for summarizing content of your dataset. So let's just run this summary function on empty cars dataset. And the outcome is for each variable, we have one chunk of summary over here, another one goes like this. It shows the minimum, first quartile, median, mean, third quartile, and maximum values for each variable, which is a quite nice summary. However, it's not as detailed as we may want or we may prefer. However, to quickly see content of your dataset, minimum, maximum values, and mean and median. So this is a really good, useful function. Since AM2 and VS2, the variables that we just defined over here, since they are character-based variables, so there's no minimum maximum for them anymore. So that's why it says classes character and modus character. So let's say we would like to do a more detailed summary. So I will use the summarize function from the dplyr package. So in this case, I'm just sending the empty cars using the pipe into the summarize function. And I would like to create a new variable called mean underscore mpg, which is going to be the mean of mpg. SD underscore mpg, which is going to be the standard deviation of mpg. Minimum underscore HP is going to be minimum horsepower, and maximum underscore HP will be maximum horsepower. And N is a nice function in the summarize function. It's a nice feature. It counts and gives you an N count basically. So I will just run this, which will return a summary table for us. So the mean MPG in my dataset is 20.09. The standard deviation is around 6.027. And minimum horsepower is 52. The maximum horsepower is 335. And I have 32 cases in my dataset, which is true because we already know that empty cars dataset has 32 rows. So I can also just do additional summarizations by group. So let's say I would like to summarize the mean MPG, standard deviation of MPG, and also N count, but I would like to do it by group. So in this case, I use the group by function first to split my data between AM2 and BS2 variables. And I'm using a second pipe which sends the output of this part into the summarize function. A summarize function will split the mean, standard deviation, and N counts based on the group variables that we just specified over here. So let's just run this. So it will print the mean MPG, standard deviation of MPG at N values, N count based on transmission over here and AM2 and BS2 variables. So this is a really nice way of summarizing your tables. However, if you want to do it in a more compact way, you may also want to check out the SchemR package. So let's just say we would like to use this. I'm installing and activating the package. Remember that once you install a package, the package is yours. You don't have to reinstall it anymore. You only need to activate the package using the library. So this schemr function has a nice, this schemr package has a nice function called skim. So skim quickly gives you a summary. So that's what I'm going to run over here to summarize and cars data set. So it says in the output in my console, I have 32 observations. I have 13 variables, and these are the variables that are based on characters rather than values. And the following variables are all numeric. So as you can see, you just see the N count, mean, standard deviation, and like different levels of percentiles, 50th percentile, 75th, 100. It goes like this. And there's a little column over here, which is the histogram. So it's not a big histogram plot for the variables, but however, it may still gives you some insight into what variables you have and how they will distribute. I can also use the group by function to create the summary table by groups. So let's say I would like to split my output the summary table by AM2 and BS2 variables, and I'm using the pipe to send this group outcome to the skim variable. So in this case, this will just print a long table because this time it just splits all the cases based on AM2 and BS2. So you will just see the N counts and other variables will be automatically. So it will be a more useful summarization. So finally, so let's just say there are like you would like to remove a certain variable from your data set. So how do you do that? In order to just remove this, so let's say one of the variables that we would like to remove is this called like WT dataset, WT column. And in order to remove this WT column, which is already here, so I just define empty cars $WT is equal to null, this is the operation the symbol in R equals null, but this will just make that column in dataset null. And when we just run this 2 and I use the head function to see what happened to the WT, as you can see, we don't have that column anymore. So null removes a certain column depending on whichever columns you want to remove. Another useful feature of R is to deal with missing values. So, for example, let's say I'm just creating pseudo missing values for the MPG variable. So I just choose empty cars, $sign over here for MPG, and I just say that give me the first 3 values of MPG and make them NA, which is missing, not available. So this will just, again, let's just run it and see the impact of it. So basically I just manipulated these 3 values from the first, second, and third row, and I made them NA, which is missing. And as you can just see in the next section, if I just ignore missings in my data set and I try to summarize my data, and you will just see messages like this. Because R, unless you specify what you want, doesn't know how to handle missing values. So that's why we need to just specify an additional comment, additional feature, which is na.rm equals true. In this case, we are just saying we are saying to R that we would like to remove all the missing values and calculate the statistics of the missing values are removed. So in this case, I'm using the summarize function to create a mean, MPG, and standard deviation of MPG. But since my variable has missing values, I have to use this na.rm. So, and I was running this. As you can see, this time I was able to print mean MPG and standard deviation of MPG because I specified na.rm equals to true, which means remove the missing values, so that the operations can be done. Alright, this is pretty much like the end of our lecture 2 part 2. So before you just move to the second following lectures, like the lecture 3, so what I ask you to do is to run everything under this packages underscore to install.r. So highlight all of them and click run, update, or install all of these packages unless you already have them. But it's always good to keep your packages up to date. So just install all these packages that we will be using in the later lectures. So, and after this, all the packages are one by one installed, which may take some time. So I want you to just run our, basically activate our package, ADSUR package, apply data science using R. And using this package, you will just complete some exercise. Basically, what we need to do is to activate our package and run this line. So for each lecture, you will have to do the same thing. So for example, run that exercise lecture equals to lecture 2. So we'll give you the exercises related to lecture 2. So when we just move to the following lectures, you will have lecture 3, lecture 4, and it goes like this. So you will be able to run. So when you just run this statement, it will open a new window in your computer. So that new window will just show you a bunch of questions and exercises that we need to follow. So, and they are pretty much like an R program, but in an HTML format. So you are seeing the R input and output within the same place, but in an HTML environment. So this is the end of our lecture here. So like I said, please just install all the packages over here. I already just shared this with you, so you can download or you can just type on from this slide. And after all the packages from this list are installed and run this 2 lines, one will activate our package for this course. The second one will activate the quiz for lecture 2. You will have a bunch of questions to answer. So, alright, this is end of our lecture 2 part 2. So from this point on, like I said, we will continue using R and R Studio. Hopefully this is going to be a good introduction to get you familiar with R or refresh your memory and just remind you about certain R features. Um, so after this point, like I said, we are moving to lecture 3. So we will just start doing more data science related activities. So I will see you in the following lecture.